the responsibility of students to attend classes. And those who have attended also should actually have the class and not always be delayed by those who don't want to attend. So I think we continue and pray and hope that we'll get better numbers as we move on. 2506 and 2508. I'm only 46. So yesterday, and I know it has been a marathon. Yesterday we were discussing the central react muscle relaxant. We were able to move up the benzo. What is this now? That's one. us now start 49, right, improvement. So as I was saying, we were looking at the muscle centrally acting muscle relaxants. You were able to look at a number of classes, gave examples, looked at the ICI-4 ones, that they are going to study the benzodiazepines later under CNS 1, which you should have started with. So I am hoping that we can finish the other two or three drugs remaining, and we start on the CNS stimulants. Again, not a very big topic. And therefore, if we do not finish today, you can still get me another lesson tomorrow, and we finish off. Oops, a loss of my connection, sorry. Telling me a loss of my connection. Unanisikia? The connection back. Umeniambia loss of my connection. Can you hear me? Etao Julius, you can hear me?
Yes, we can hear you.
Yeah, because I got a message, a loss of my connection. So lecture perhaps by tomorrow, we should manage to finish. And that's why I was requesting. It's easier for us to do that. So we had gone up to benzodiazepines. I did highlight the structural features of the benzodiazepines that are necessary for activity. We did mention the halogen, the electron withdrawing group at position number 7. And a small alkyl group at position number 1, more often than not a methyl group. But we do have other benzodiazepine like flurazepam, which have bigger groups and they are metabolized to smaller groups. A carbonyl group or an electron donating group at position number 2, where for those benzodiazepines that have that structure, again increases activity. We mentioned that that compound does not undergo phase 1 metabolism. It goes straight to metabolic drug-drug interactions, and of course it's more polar, shorter duration of action. We mentioned that about the phenylrine at position number 5, we said it is necessary for activity. We mentioned the double bond. It should remain at position 4-5. If you shift it, there is loss of activity. But it can be absent, like tension of activity. We did mention also the phenylrine can have halogen subprime with increase in activity. Then I did mention yesterday that for the benzodiazepine, they are also classified as per their duration of activity. But their duration of activity, unlike the barbiturates, is because of their metabolic process. Those with a long metabolic process to give active metabolites like diazepam to non-diazepam, which is active, to oxazepam, which is active, have a longer duration of action. That we discussed of diazepam. Then we had alprazolam. Alprazolam has an intermediate duration of activity. And what are we saying? We are saying, in fact, we do have long duration, intermediate, and short duration. It has an intermediate duration of activity, and we are saying this is because it has that methyl group. It goes rapid metabolism to the alcohol catalyzed by cytochrome P450, and then the alcohol rapid, quite some rapid metabolism, and therefore it has an intermediate duration of action. Then we did mention, I think, the last one, and the hydroxyl group we have already discussed. So when we look at this benzodiazepine, the metabolic process will determine their duration of activity. And even as I have said, whether they will have a lot of drug-drug interactions, especially for drugs that are metabolized by cytochrome P450 enzymes. You know, when you give them together or concomitantly or together or concurrently, there will be drug-drug interactions. So those benzodiazepines with a 3-hydroxyl group already have a functional group. They really do not require the cytochrome 450 enzymes. Mainly, especially if they do not have an alkyl group at position glucuronide conjugation, which requires the glucuronide transferase rather than the cytochrome P450, and therefore lesser drug interaction. So I think we had gone up to there. We had mentioned, I think, their metabolism, if I'm not similar to that of barbiturates, but I did emphasize that the benzodiazepine increase the frequency of the chloride ion channels opening, and the chloride ion channels, which are part of the GABA receptor, the ion-gated chloride channels are part of the GABA receptor, are inhibiting of those channels. You bring about inhibition, and therefore you will bring about muscle relaxation, as we have already discussed. And metabolism, we are saying they are most benzodiazepines are oxidatively metabolized by cytochrome P450, conjugated with glucuronide, and then excreted almost entirely in the urine. Microsomal oxidation, that is an N-oxidative N-dealkylation and aliphatic hydroxylation for the ones that have, and can also and conjugation also to glucuronide. And then we look at some of the benzodiazepines, you can see that is diazepam, and you can remove that group there, oxidative N-dealkylation catalyzed by cytochrome P450, you get the dismethyl diazepam, or NOR, diazepam. It doesn't have that, but it is active, and therefore we bring about activity. Then from there again, oxidative N, it gives us the hydroxyl group there, hydroxyl group at position number 3. It is still active, and now it is after that compound can go direct. It's going to conjugation and no activity, and removed from the body. And also the diazepam can also, without oxidative N-dealkylation, go straight to oxidative hydroxylation of position number 3 and leading to conjugation. But this compound is also active, and therefore that is what is giving that compound diazepam a long duration of activity, because of the fact that its metabolites are also active. I did mention it is a triazolo 1, 2, 3 position, a triazolo 1, 2, 3, 4, 1, 2, 1, 2, 4 triazolo benzodiazepine. It does not have a two-one, as we say, as you can substitute at position 1 and 2. It has a fused triazolo ring, which that includes even the muscle relaxant activity. When it comes to metabolism, I mentioned that group there, and that group can regularly that compound that goes again, the rapid alpha hydroxyl alprazolam, and that is a product that goes, this is a major route of metabolism, and that goes rapid conjugation to give us the glucuronide conjugate, and that is what shortens the duration of action of alprazolam compared to the diazepam. It can also, at this particular position, also undergo hydroxylation to give us the 4-hydroxyl alprazolam, and that of course also undergoes glucuronic conjugation. Another one for most of the benzodiazepines, almost all of them, even diazepam, there can be cleavage followed by oxidation. Cleavage at that point, CH2, OH, because at that time it doesn't have that. So it is this immediate hydrogen protonation followed by cleavage of the 4-5 bond, position 1, 2. So this time it's a bit different. Oh, sorry, I'm showing you at the wrong place. I know. It should be down here. It should be down here where there's a double bond here. The double bond there. So the cleavage should be at this point there, and once that cleavage occurs, then you will find that this group here is oxidized to the ketone when the cleavage comes there, and the resultant group there, it's an NHCH2OH. So CH2OH. Whenever you have an imine, when the cleavage occurs, you lose the nitrogen, and the nitrogen is replaced by an oxygen. So you just lose the oxygen, the nitrogen is replaced by an oxygen, results in reduction or in oxidation to an alcohol. So we can also get the benzophenone. But the benzophenone, as I have said, is not only for alprazolam. It can happen also for other benzodiazepines, which because of the imine group, many of them do have the form the benzophenone. The only advantage of this one, this benzophenone, is that this and this can combine. These molecules can recombine to give us the original compounds. That can happen. Alpha hydroxylation, that all the others we have mentioned. So alprazolam is excessively metabolized in humans, primarily by cytochrome P450, two major metabolites in the plasma, the 4-hydroxy alprazolam and alpha hydroxy alprazolam. The benzophenone derivative is also found in humans. So of course, these are found in smaller quantities. So, and as I have said, the benzophenones are not only for alprazolam, they can happen even for diazepam. The diazepam can also be hydrolyzed to the benzophenone, but like diazepam, the ones we do not have a heterocyclic ring up there, they go further until they go further and the amide is also removed such that they are completely hydrolyzed. But as I said, we are only looking at the major metabolic pathways because for those who have not studied these compounds, you would study them under CNS1 as the sedative hypnotics and anticonvulsants, and therefore you will study them in more details. And we will try and make sure we will try and make sure that the dean make sure that the units are taught in the right order. You start with the CNS1 and then you go to CNS2, so that now it is easier for the students to understand. Razepam also is hepatically metabolized by cytochrome P450 enzymes and extensively conjugated to the 3-O-phenolic group. And we said because this ring is there, again, it can go oxidative hydroxylation at that ring. And you can see the razepam has a chloro group there and has a chloro group there also, just like, of course, all the others also. So then it has an NH there, it has the hydroxyl group there. So it can undergo oxidative hydroxylation at that position of that ring. And also it can undergo direct glucuronic conjugation, as we have already discussed. Different drugs, though the routes of metabolisms are similar, but different drugs might differ in their major metabolic pathways because of structural differences. And I think that with that, we summarize that is a summary of the benzodiazepines, which can be used, and we can give those 3 examples: razepam, alprazolam, and diazepam. And as I said yesterday, benzodiazepines are not selective in their biologic activity. They can be muscle relaxants, they can be anticonvulsants, they can be sedative hypnotics. This is because they have the gamma receptors. And I told you the gamma receptor, again, not the GABA, the gamma aminobutyric acid receptor, gamma aminobutyric GABA receptor. It has several subunits. It is a complex receptor with several subunits. It has alpha 1, alpha 2, B1, and so on. And you find that the benzodiazepines are not selective. In the type of alpha receptors they bind. They response once some of the GABA receptors, some of the alpha receptors will bring you muscle relaxation. The benzodiazepine to have several activities. Again, when we come to discuss antidepressants, therefore, they only give you sedation. So it's important to note that benzodiazepines do not just have muscle relaxant activity. 7, they can be used as anticonvulsants. And therefore giving various types of activity because the barbiturates and benzodiazepines go for an narrow. They potentiate the activity of GABA, but you can have drugs that are and one activity relaxation, and one of the drugs is baclofen. Again, this is a drug when you go out there. For those who have been out there, I hope you are able to see that drug, and it is a very good muscle relaxant, baclofen, and it is a substituted analog of GABA because it is competing with GABA for the same receptor, GABA receptor, and therefore there must be structure difference to give it higher lipid solubility for it to get the receptor, and also to give it but not to be an antagonist, still to be an agonist. And when you look at baclofen, you can see indeed it is a substituted gamma aminobutyric acid. When you look at gamma aminobutyric acid, this is the structure of gamma aminobutyric acid. That's the amino group, that is alpha, that is beta, that is gamma. So alpha, sorry, this is alpha, yes, beta, and gamma, and then from gamma you go to delta. In relationship to, you're supposed to be saying in relationship to the carboxylic acid, so that is alpha, that is beta, and that is gamma. We, again, always remember the carboxylic acid has the first priority, in given the first priority as a substituent. So you name that compound as a derivative of a carboxylic acid. So that is the alpha position, that's the beta position, that's the gamma. That's why we call it gamma amino 1, 2, 3, 4 butyric acid. So when you look at acid, that is the alpha carbon, just like that one. This now is the beta carbon, and this here is the gamma carbon. So the difference between baclofen and GABA is that on the beta carbon, one of the hydrogens has been replaced with a phenyl or with a chlorophenyl group with written the para chlorophenyl group with a retention of an increase of agonist activity. Of course, when you put this group again, para position, you have put a chloro group to block metabolism. This group, both the phenyl group and the halogen, increase lipid solubility for this compound. They also can increase, as we said, the halogen can influence the distribution of electrons within the phenyl ring, improve on the binding. It can also help in increase, we have said, increase lipid solubility of the phenyl ring and the drugs. It can also influence the electron distribution. And once the electron withdraws, especially through resonance, then you find, especially through inductive effect, the electron withdraws, especially through inductive effect, you find that they will result in this ring having a slight positive, a delta positive, and therefore that can influence on the type of bonding that that group can have with the receptor. So the substitution is usually very important. So that is baclofen, very, very important, an agonist on the GABA agonist, and therefore it will do the same work as GABA. How do we style? 3, 4 chlorophenyl, doing condensation with nitromethane. Nitromethane, we are using Triton B. Triton B is an organic, base. It's actually an organic base It is see whether I can remember benzyl, benzyl, trimethyl ammonium hydroxide. It's a quaternary like that. Trimethyl. So it's benzyl. That one is benzyl. Trimethyl, three methyls, ammonium. So hydroxide, the vicinity, there is a hydroxide, not hydroxyl, but hydroxide. Remember, hydroxide is when you have an OH which carries a negative charge. That's what you call the hydroxide ion. The hydroxyl group is not an ion nature, hydroxyl group. That one you find it in organic molecules, whereas the hydroxide, you find it in aqueous solutions. So indeed, this is it's a quaternium ammonium ion, and it can be used as a catalyst. It can be used as a catalyst, of course. Also, it is working also as a solvent, but more so it's a catalyst to be able either for alkylation, condensation, and that kind of reactions. You can see this like a condensation. So the triton B is benzyl trimethyl ammonium hydroxide, which can act as a catalyst. Then you have lanyl, nickel, and hydrogen. This is again a reducing agent. This is a group which you can use for hydrogenation or a reducing agent. When you call it lanyl, it means it's the kind, the form, the kind of it's kind of can you call it? Instead of it being metallic, it is actually spongy. It is the way it has been. The word which I'm forgetting, I will get it. So it is spongy and because of its nature, the way it is acts as a very good reducing agent, and that is what you're doing. You can see, or hydrogenating agent, it brings about hydrogenation. You can see you have a double bond here. So if you look at this final product, there is hydrogen, there is reduction there. Reduction is also addition of hydrogens. So these compounds are acting as reducing agent and also as a catalyst for that reaction. As we have said, triton B is a catalyst, whereas lanyl and nickel in hydrogen is actually a very, very potent reducing agent. Then it will form that compound, and you can see this is an ester. And whenever you hydrolyze an ester, you will get an alcohol and the carboxylic acid, and that definitely will give you baclofen. So that, again, it's important. We have come across two new agents, reagents there. Those are reagents, triton B and lanyl nickel plus hydrogen. Those are very important and important reagents. One serving as a catalyst, it's an organic base serving as a catalyst, and the other one also serving as the compound. It also serves as a catalyst also for hydrogenation or reduction reactions in organic chemistry. Reactions, alkylation reactions, and such reactions. Addition reactions, alkylation reactions, and condensation reactions. This triton B can act as a catalyst. Has rang my bell. I think it's my worker, so let me open again. Sorry about that. We continue. About those compounds, I've talked about trane and nickel with the hydrogen, which is spogy. And I think when they talk about spogy, it means it has many porous. It's not crystalline form. It is actually porous, and it is important in order to allow for maximum surface area for the hydrogen, so that now it can bring about good activity. Then we move on to the next. So that is the synthesis of baclofen. Baclofen, again, very simple. And when you look at the structure, I hope you can appreciate that baclofen, it will be able to bind the receptor. Base group there is important to give it chloric conjugation. You can see because of this group, the phenyl ring does not undergo metabolism. The main metabolism is through this group here. The amino group can undergo oxidative and dealkylation. I mean, not dealkylation, can undergo deamination. Again, oxidative deamination. And once it undergoes the oxidative deamination to give us a hydroxyl group. Once you have a hydroxyl group rapidly conjugated and excreted, so that's the mid route of metabolism of baclofen. Baclofen used for treating spasticity. Again, it's a muscle relaxant as postmatic agent that reduces muscle relaxation. It binds the GABA receptors. We have said it reduces the release of excitatory neurotransmitters in the presynaptic neurons. Again, that's another added advantage. It reduces the release of excitatory neurotransmitters in the presynaptic neurons, stimulates inhibitory neuronal signals in the postsynaptic neurons. So we are saying not only does it bind GABA and bring about enhance, inhibit the release of the excitatory neurotransmitters, which we did mention is usually glutamate with glycerin be a co-agonist in the MDA receptors there for amino 3 for chlorphenyl butanoic acid. That again, it's not difficult to know the group that is different is that group. Chlorphenyl group, it's a benzene ring substituted with a chloro group or chlorine atom at the para position, butanoic acid chain, a 4-carbon chain, then amino group at the 4 position, and a carboxylic acid group at the position 1. That is the structure. Chemical features, perhaps that's more important. The presence of the amino group contributes the drug's ability to act at a GABA B receptor. This drug does not, like the benzodiazepine. So again, these receptors are complex, many of them. So amino group, the presence of the amino group, you can see the gamma aminobutyric acid. The amino group is very important for identification of the GABA receptor. Whether it's GABA A or GABA B or GABA C, the amino group is important. The chlorphenyl group enhances the lipid solubility of baclofen, as we've already said, aiding in its ability to carboxylic acid is crucial for the drug's interaction with the receptor. So both the amino group, I think these things are obvious. Baclofen acts G protein coupled receptors found primarily in the central nervous system. The binding of baclofen to these receptors neurotransmitter release. That one we've already mentioned. Once you reduce the excitatory neurotransmitter release, you bring about depression, decrease of muscle tone, and therefore relaxation. Reduces the release of excitatory neurotransmitters such as glutamate and aspartate by inhibiting calcium influx into presynaptic terminals. Presynaptic inhibition, activation of GABA B receptors leads to the opening of potassium channels, again causing hyperpolarization polarization of postsynaptic neurons and reducing neuronal excitability. Baclofen, the two mechanisms, because the frequency and amplitude of muscle spasms, providing providing relief from spasticity or that rigidity of the muscle. Absorbed from the gastrointestinal tract after oral administration. Although, of course, it has the carboxylic group, it has the amino group, it is still because of the chlorophenyl group, can still be absorbed. It is distributed throughout the body, including central nervous system, crosses the blood-brain barrier, but its penetration is limited due to the polar carboxylic group, as we expect, but it will still penetrate. Baclofen undergoes, you have said, minimum metabolism primarily in the liver by deamination. We are saying minimal because with the carboxylic group, it can still be excreted as the carboxylic compound because the carboxylic group also is polar. The drug is primarily excited also unchanged in the urine because of the presence of the carboxylic group and the amino it can undergo deamination to give us, as we have seen, to give us the carboxylic acid derivative. I think that's what we did mention. The carboxylic, not the carboxylic, but the alcohol, can undergo deamination to give us the alcohol derivative, and then the alcohol derivative can be undergo protein conjugation, and it will leave the body. We've already said. Then clinical uses, and we have already mentioned for spasticity associated. So mainly, let us stick to, we are not pharmacologists, so let us stick the fact that it is a muscle centric. Brains, drowsiness, dizziness, weakness, fatigue, headache, nausea, and hypotension. So those are mainly associated with mode of action. Fear side effects that it can also cause seizures, confusion, respiratory depression, and withdrawal symptoms upon abrupt discontinuation. So again, this is important. We tamper them when they are stopping to take them. We try to tell them, don't withdraw mara moja. If you are taking 2-3 times daily, first of all, reduce to twice daily, then reduce to once daily, and then now you can be able to withdraw the drug. Because again, remember when the patient is taking the drug, there is a lot of depression of the CNS activity. So with a minute, and you see, when you depress the CNS, and that is why you are getting hypotension, and that is why when the patient withdraws this drug, they should do it slowly to avoid serious toxicity. Central nervous system depressant, it can enhance the effects of other CNS depressants such as alcohol, the benzodiazepines, the respiratory depression, especially the opioids cause respiratory depression. The benzodiazepines not to a very high extent, alcohol also not to a very high extent, but they can cause a minimal, not significant on their own. But once now you give them in combination, and we have said baclofen can cause depression, then you can have enhance the hypertensive effects of antihypertensive drugs, because we have said it can cause hypotension. It's slowing down the catecholamine activity or the neurotransmitter activity, and that, of course, the heart also requires those catecholamines for it to function, and therefore of the gamma aminobutyric acid receptor. It's a specific gamma B and for whereby you have increased chloride influx, and increased chloride influx, then you have depression that will give us the muscle relaxation. So we got there. I think this might be the last one, and this we are calling it cyclobenzaprine. Cyclobenzaprine, and cyclobenzaprine is a member of the tricyclic drugs. Tricyclic drugs are drugs with three rings that are attached to each other. the main group of tricyclics that we study is the tricyclic antidepressants. We have even the phenothiazines are tricyclics, but we don't call them tricyclics. We give them the exact name, the phenothiazines. We give them the name, the phenothiazines. So the main drug antihistamines, we did look at tricyclics, but we gave them the exact names. Are they piperidine derivatives or what they are? So when we talk about tricyclic, mainly tricyclics is associated with tricyclic antidepressants. So you usually see TCA. TCA is tricyclic antidepressants. And again, when you come to study the antidepressant, because antidepressant is the main subtopic, you will now again into detail about cyclobenzaprine. Try to see what are the structural differences between the cyclobenzaprine, because it's a tricyclic, but it's not an antidepressant. Of course, it's being used as a muscle relaxant. So you can see those, when you use something as an antidepressant, it is increasing the levels of the catecholamines. But you can see this one is decreasing the activity of the catecholamines. So the antidepressants and the cyclobenzaprine are acting oppositely, because of that, when you talk about a tricyclic antidepressant, you have depression. If you have depression, you have low levels of the catecholamines. So you give tricyclic antidepressants to increase the concentrators. When you use it as we use a drug as a muscle relaxant, we have talked about it is depressing the system. So although this is a tricyclic compound related to the tricyclic antidepressants, it acts in an opposite manner, where here it is bringing a depressant activity, where the antihistamines are bringing in a stimulatory active important for us compounds, although they are tricyclics. The reason why they have structural resemblance with the tricyclic antidepressants, but there is a small change which makes this compound have a different conformation, and therefore instead of binding the antidepressant receptors, it goes for the muscle relaxant receptors. So cyclobenzaprine is a tricyclic compound. Structure is similar to the tricyclic antidepressants, or what we call the TCA, particularly amitriptyline. Then we have amitriptyline, we have imipramine as you move on. But for the 5 ones, amitriptyline, protriptyline, imipramine, they are not. So when I think it's important for us, before we even look at the key structural features, to be able to see the structure of this compound. When you look at this, position 1, position 2, 3, 4, that is position 5, position 6, position 7, 8, like 1, 2, 3. It's a tricyclic. This is a phenyl ring, that's a phenyl ring, and you can see this is a cycloheptide. The drugs, there's a very, very small structural difference. Very, very small. If you look at this carbon, so it's 1, 2, 3. So this is also methylamino, like in the phenothiazines, which we have looked at, like in the antihistamines that we have studied, and like even the who has written it badly. I've left an O. To be cyclobenzaprine. If you look at that structure, you see it has a double bond at position. I mean, one of the compounds at position number 5 is amitriptyline. So if you look at amitriptyline has a double bond at that position, but it has saturation at position number 10, 11. But when you look at cyclobenzaprine, it has unsaturation at position number 10, 11. We can compare these also with another, the protriclin. For PRO, protriclin, bond there, but this bond is not there. So when you look at protriclin, there's middle ring. So you have to start the benzene ring. With this pen, it's quite a challenge. They agree to. So when you look at protriclin now, the double bond is there. So that is the only protriclin has a double bond here, but on this, and it has a carbon at this point. It has a carbon at that point. It does not have a nitrogen, but it doesn't have a double bond. It also has a single bond at that point. But when you compare it now, and then amitriptyline has a double bond there, does not have a double bond there. So the major difference is the fact that this compound, compared to amitriptyline to protriclin, where it has the 10-11 double bond, but different from protriclin, it is also structurally similar to amitriptyline, but amitriptyline does not have a double bond at position 10-11, but amitriptyline has a bond at position 5. So what we are saying is that for the TCAs, they only allow for one bond. And when they allow for one bond, as we're going to, for those who have studied it, when it they have that only one bond. That bond allows for a certain folding. These drugs are able, whether they have the bond or not have the bond, they are able to fold in a certain manner along this line I've drawn there. They are able to fold along that line. In other words, this position a V shape. A V shape, they form a V shape, and therefore this portion here and this portion here, it is like there is an angle. So there's this portion and this portion. So there's an angle there, and there's this portion on this side, and there's this portion on this side, and there's an angle. There's an angle in between. There's an angle which is there in between those compounds. And when you have the drugs like amitriptyline and protriclin, they often have a one double bond. The conformation, because when they fold, they form what we call conformers. They will form the shape of the conformer that is formed, the shape of the resultant compound, because the folding must occur is the shape that is required to bind the antidepressant receptor. When you have now the cyclobenzaprine, which has the two double bonds, each folding from the conformer is only right. Because of that structure difference, the conformer it forms, you'd have difference in the angle between the two benzene rings. There will be a difference in that angle, and the conformer that is found, again, is very right. to bind the muscle relaxant receptors. So that is the difference in these two drugs. And of course, when you come to look at the TCS mode of action. So that, but in our minds, let us understand that structural change where this compound has a double bond at position 10, 11, and a double bond at position 5, it allows for the folding, for the conformation. The conformer that is formed is such that the shape of that conformer best suits or best optimally binds the muscle relaxant receptor rather than the antidepressant receptor. And that is why this drug is able to act as a serotonin antagonist, and therefore bring about muscle relaxation activity. So interaction with serotonergic and noradrenergic systems, cyclobenzaprine acts on the descending serotonergic and noradrenergic pathways in the brainstem, reducing muscle tone by modulating neurotransmitter release. In other words, on the serotonergic or serotonin neurons and noradrenaline neurons, it will act as an antagonist, reduce serotonin, and therefore bring about muscle relaxation. 5-HT, an adrenergic receptor antagonist, that is what it is. Relaxation action is due to the blockade of serotonergic descending systems in the spine structure. Because of that difference in structure, then it can bring about the difference in activity. And then now we can finish off. We can talk about the key structural features, the tricyclic core, the cyclobenzaprine has a is a cycloheptene, which differentiates it from the cycloheptane ring. Even the others do have a cycloheptane because of the double bonds on the phenyl ring, but per se, they do not have an endocyclic. I think the best is to say that the others do not have an endocyclic double bond, because even if you look at the others, they are really not cyclocorrect. And this, we cannot say this is a cycloheptane. See, double bond is here, and that double bond, it is shared by this ring and that. But a cycloheptene, so I need to correct that. Both do have a cycloheptene, but for the cyclobenzaprine, there is an added double bond at position 10, 11. Let us be very specific here. Let us make that correction. Indeed, for all of them, the central ring is a cycloheptene because the two benzene rings have double bonds. So that central ring is also unsaturated in on the portion of the benzene ring. So all of them do have a cycloheptene, but what differentiates them is that the cyclobenzaprine has also a double bond at position. It has a double bond at position, and cyclic double bond at position 5. I think it's very important for us to be very specific there. I mean, sometimes the information is not very clear. I mean, we get notes from many places. So we are therefore saying what differentiates the cyclobenzaprine from the tricyclic antidepressants is that its cycloheptene ring has a double bond. Please note that in your notes. Has a double bond at position 10, 11. That's an endocyclic double bond at position 10, 11. And an exocyclic double bond at position number 5. At position number 5. And those two double bonds will give it the conformation rather than on the tricyclic antidepressant receptor. And that is the main difference. So let me kindly correct that statement such that it is that clear that this drug has two double bonds, one an endocyclic double bond at position 10, 11, It's a cycloheptene 10-11 double bond, and also an exocyclic double bond at position number 5, whereas the others either have an exocyclic double bond at position 5 without the endocyclic bond, do not, and therefore that molecule to fold, it will be skewed, SKEWED, be skilled in a certain way such that it maximally fits the muscle relaxant receptor rather than the other receptor. The alkylamine side chain, again, this is essential feature for activity. The side chain is typically a propylamine, but of course, it's not really a propylamine. It is it's a propylamine, propyne, because of the double bond. Again, it is important for us to correct that. I didn't note those mistakes. If you look at that double bond, this double bond here, it is not propyl. If it's propyl, this would be a single bond. But you see now this is a double bond, so it makes it propyl. Propynyl, because of the propene, it's a propene, it's a propane. It is an alkene, propynyl, it's a propynyl, but what we are saying, it is very similar to that which you find in the tricyclics. That is not very different. If you look at amitriptyline, that is the kind of sites you have much effect on the activity. So we are talking about it and contributes to its binding affinity to the receptors. The double bond, the presence of a double bond in the central ring, that's a position, let's make it at the cyclic double bond at position 10-11, makes it ring, is crucial for its unique conformation or structure, distinguishing it from the other TCAs. Structural resemblance, when you look at protriptyline and the cyclobenzaprine, there would be the difference that in protriptyline there is an sp3 carbon at position number 5. In cyclobenzaprine, there will be an sp carbon at position number 5. So please make sure those are the notes. Like it's not sufficient enough. So there is that compound we are calling protriptyline. It has a double bond at position 10-11. It does not have a double bond at position number 5. It has an sp3 carbon at position number 5 and sp2 carbon at position 10-11. So that again makes a difference when you compare with the cyclobenzaprine, which has an sp2 carbon at position number 5 and an sp2 carbon at position 10-11. So, and that little unsaturation, that added unsaturation into this compound allows it to form the conformize, I have said again, which allows it to sit on the receptor. But we are saying in terms of carbon atoms, a 3-carbon atom chain is necessary. A 3-carbon atom chain with a protonable nitrogen and CNS. Substituents on the aromatic ring, you find it as none. The absence of differentiates its activity profile from any other tricyclic compounds. We're not now talking about just TCAs, like we're not just talking about tricyclic antidepressants. Like if you have phenothiazines, of course, as antihistamines, they do not require halogen, but as antipsychotics, they require halogen. So we are saying, again, this compound is very specific. These compounds do not require a substitution on the phenothiazine, not on the, sorry, on the benzene ring for again, for them to be able to maximally bind the receptor. Structure activity relationship, tricyclic ring, we have already mentioned. The tricyclic ring is essential for maintaining the structure, have the 2 bonds, it will be skewed in nature it is going to, and type of ring, where it's a cycloheptene, are crucial for its muscle relaxant properties. I think what we need to add there, specific arrangement and type of ring, cycloheptene with a double bond at position 10, 11, and an endocyclic double bond at position 10, 11, and an exocyclic bond at position number 5. So kindly add that there for me, are crucial for its muscle relaxant property. The tricyc structure allows for binding to the serotonin 5H2 receptors and alpha-adrenergic receptors, which is critical for its muscle relaxant activity. It also shows affinity for H1. There is structural similarity with the H1 phenothiazine derivatives and muscarinic receptors contributing to sedative and anticholinergic effects. Of course, if it has anticholinergic effects will further increase muscle relaxant activity, because we did mention cholinergic effect brings about contraction. Anticholinergic effect add the relaxation. So anticholinergic effect is quite helpful in terms of muscle relaxation also. The tricyclic core increases lipophilicity, as we have mentioned, facilitates central nervous system penetration, which is essential for its action as a central muscle relaxant. Side chain length and substitution, the propylamine side chain length is optimal for activity. Propyl. Maintain, to make it even simple. The 3-carbon chain is optimal for activity, shorter, because we are not looking at the unsaturation. So we can mention the 3-carbon chain is optimal for its activity. Shorter or longer chains may reduce efficacy. Substitutions on the side chain can significantly alter binding affinity and selectivity on the receptor. So we do not want branching. We just want it as an aliphatic 3-carbon atom chain. Of course, it can have the unsaturation, and that is what we require for maximum activity. Double bond in the central ring. The double bond introduces rigidity to the molecule, which is necessary for its distinct pharmacological profile. Again, as we have mentioned the absence of halogens, and like some of the TCAs with halogens, like chlomipramine. So unlike some of the TCAs with halogen substitution that enhance antidepressant activity, cyclobenzaprine, lack of such group, again favors muscle relaxant activity. Again, that we're just repeating the same. Pharmacological implications, CNS activity, the ability to penetrate the CNS and interact with the noradrenergic systems, and that underlies its primary therapeutic effect. The anticholinergic effect, where these contribute to side effects, they also enhance the muscle relaxant properties. Sedative effects, I thought the histamine receptor binding contributes to sedation. That one we know, beneficial in acute musculoskeletal conditions. Arrest is necessary. So some of its side effects, like its anticholinergic for its relaxation effect. This we have already looked at, and we have already mentioned that its main mechanism of action is through antagonism and the serotonergic 5-HT2A and also the adrenergic receptors, bringing about modulation or decreasing the muscle tone, and therefore bring about relaxation. And I think with that, those are enough. And I've said it's mine is just to give you a few examples to add, at least to keep as we look at the different groups, we also keep improving on our chemistry. And I think I read the muscle relaxants there, unless if there's any question. Well, I need to take some water or something. Any question? Can we move on a bit? I can introduce the CNS stimulants. So this will be now, I think this should be this the CNS stimulants. And so once we do one, the other one will be very simple. Again, as I said, these are not as complex as the other things that we have done. CNS stimulants, and the name tells us what these drugs do. Central nervous system stimulants. These are drugs that increase the levels of certain chemicals. And of course, they must be increasing the levels of these chemicals in certain areas, because they can increase, like when you get dopamine increasing in the limbic, mesolimbic area, mesocortical area, you find that you get a psychosis. So again, it must be in very, very specific areas such that it results in stimulation. Drugs that increase and noradrenaline in the brain. And what do? So once they increase, remember the catecholamines, these neurotransmitters, when their levels increase, noradrenaline, dopamine, there's increase in alertness. That there's increase in attention, there's increase in energy, there's increase in physical activity. But we must be specific that, of course, they must be increasing the levels of these neurotransmitters in very specific areas so that you get the alertness, you get increased attention, you get increased energy, and you get increased physical activity. Central nervous system stimulants also raise the blood pressure and increase the heart rate and breathing rate. So because this pathomimetic stimulation, so once you increase the noradrenaline, then the chronotropic effect of the heart, and therefore you will have increased heart rate, you will have increased blood pressure, and that can, of course, also be quite a danger. Central nervous system stimulants, and we can also say that these are broad range. They include a broad range of agents that stimulate the central nervous system. We have what we call the analeptics. These are the one almost classically analeptics are a group of agents with limited range of use because of the general nature of their effects. It's very general. They are not specific, very, very general, and quite a number of them also cause a lot of respiratory stimulation. And if you get respiratory stimulation, my friend, so they are not the analeptics are not very, very specific, and therefore we have even moved from analeptics to very specific drugs. The traditional analeptics are a group of potent and relatively non-selective CNS stimulants. Picrotoxin, pentyl, and a tetrazole. Picrotoxin and pentyl and tetrazole are even obsolete drugs. They're just used as laboratory drugs. Like you can give them to animals. Like if you want to test the activity of anticonvulsant drugs, you can give the animal picrotoxin or pentyl and tetrazole if you give certain doses, and the animal will converse. And then you give the and you can see, or you can give the conversant first, and then you give the picrotoxin or pentyl and tetrazole, and you check the dosage of you can give the picrotoxin first, and you check the dosage of the conversions. If the compound was active, let's say like if you'd given it fast, you have given it the conversant, it means it will require higher doses of the laboratory drug, the conversant, for the animal to converse. So you can be able to check the activity of the conversants using these laboratory tools. They're just used as laboratory tools, as we have said. They cause conversions. You cannot use them as drugs. So picrotoxin and pentyl and tetrazole are both obsolete drugs, but remain valuable research tools in determining how drugs act, especially for anticonvulsant activity. We have others like modafinil and doxapran. Modafinil and doxapran are more selective. So you have the modafinil and doxapran. You can use them as a respiratory stimulant in case of spiritual depression, like the narcotic. So if you have such a patient, then you can give the safer ones, the bondafenil, the doxapran. I remember to come up with the structure, I forgot. And you can give them to stimulate the respiration because they are respiratory stimulants and they are more selective. What is important again here is to note the importance of selectivity in drugs. And when you have a drug that has selectivity, that drug will also be safer to use because it will give you a specific activity. So we are still at the central nervous system stimulants. We have looked at the first category is what you call the analgesic drugs like picrotoxin and pentel and tetrazole. Then we have the second category. We can have the methylxanthine have abused one or two of the methylxanthines. Talk about the methylxanthines. There are some people who take very strong coffee, even for them to stay awake, to be able to read. Now today I'm telling you stimulants with caffeine, which is found in coffee, of course, even in the others, being the strongest CNS stimulant. And that is why you find some people get addicted. They get addicted to tea. They get addicted to coffee. Because these are CNS stimulants. They feel alert. They keep awake. Somehow they just get addicted, but they do not know it's an addiction. All that happens is that if they fail to take the cup of tea in the morning, they will get a severe headache. If they fail to take the coffee, they will even, some of them even get withdrawal symptoms. We are also saying those are the methylxanthines. The methylxanthines include the caffeine, the theobromines, and those are also CNS stimulants. These have potent stimulatory properties, mainly cortical at low doses, but with more general effect as the doses increase. So normally, that's why we are saying, normally, you have even drugs like Cafegot, which is used for migraine, where you have caffeine mixed with something else. So it is thought that it can improve the blood flow in the brain and therefore take care of migraine and so on. So again, in low doses, they have stimulatory properties. But again, when you use them in large amounts, then they can have general effects and cause quite a lot of problems. Centrals, and they can cause you sweating, because we have said stimulants will increase the heart rate. They increase the heart rate and so on, and they increase the respiratory. Of course, to take a dose that can kill you must be a lot. So that's the other one, the methylxanthines. We're going to look at them. The central sympathomines have structural resemblance with the catecholamines, especially noradrenaline, and they will bind the receptors which are bound by the noradrenaline and bring about the same activity as compounds like methamphetamine and others. And again, we are going to discuss them. These are central acting. The amphetamine and close relatives have alerting and antidepressant properties, but are medically used more often as anorexian. Because again, very rarely do you want to give drugs to give somebody CNS stimulation. I mean, you don't use drugs to. They will increase, of course, the levels of the catecholamines, but they have a very specific way of acting, very, very specific way of acting, so that they raise the neurotransmitters that are required, and to a certain level by acting through a certain manner, and therefore bring you antidepressant activity. So very rarely you will use amphetamine or these drugs. Indeed, most of these drugs actually have abuse potential. Amphetamine, methamphetamine, and so on have abuse potential, but we have some of them that also have structural similarity or are central sympathomimetics and have found some use. And you see drugs like methylphenidate, which have found some use, but most of them are not of much clinical or do not have any clinical application. Then you have the antidepressant drugs. And now these the antidepressant drugs, the other category, again, you will study these as a whole subtopic within CNS 1 or 2. And of course, these are very important drugs that we use for those who are depressed, used most frequently in depressive disorders, and can be broadly grouped in. We have those which call monoamine oxidase inhibitors, monoamine reuptake inhibitors. And when we talk about monoamine reuptake inhibitors, we are mainly talking about noradrenaline and serotonin reuptake inhibitors. And when you study them, you will come and classify them to those which are selective for serotonin, those which inhibit both, those which are selective for noradrenaline, and so on. And you'll be able to mention, if you have not done so in pharmacology, what are the advantages, what are the disadvantages. But now we are just talking about the stimulant. If you have to look at it critically, also these ones are stimulants, but they are stimulants that have a specific mode, but some are very selective, and they are used as antidepressant agents. Also, we have agents acting and on autoreceptors. These again mirtazapine, specific mode of action. They increase, especially serotonin. Even some increase dopamine, some increase serotonin to certain levels through a specific mode of action, and therefore they can specifically be used not as stimulants, but they can be used in people who are depressed, whose neurotransmitter levels is lower, and once they are used, they will trigger the increase in the neurotransmitters and therefore relieve the depression. Classification of the drug acts. Again, these are a lot of pharmacology. I believe you'll be able to do it more. You have those ones you call the cerebral or the cortical stimulants. And these ones can be different types. We have, of course, what we call the psychomotor stimulants. So the first class is the under the cerebral cortical stimulants. We have the psychomotor stimulants, and these are electrosympathomimetics. So the psychomotor are the same as the central these agents stimulate the brain to produce euphoria, alertness, and reduce fatigue. And that is also what even the methylxanthines do. So when we talk about cerebral or cortical stimulants, these are drugs which you produce, they will reduce fatigue. And you have examples of drugs like amphetamine, methamphetamine, methylphenidate, and even cocaine. Of course, cocaine is not a drug, it's a drug of abuse. You also have the methylxanthines, which you have mentioned, and okay, also these are xanthine derivatives at low doses. Again, remember, we are very specific at low doses, primarily on the cortex. So they are cerebral cortex stimulants, and we have caffeine, we have used in asthmatic attacks. It stimulates the respiratory system, and therefore theophylline, very specific for asthmatic attacks, especially an injection. Caffeine, I've said, some of the drugs like Cafegot, I think used for migraine, you can have caffeine, and we know all of us, most of us love a cup of coffee. Theobromine is, I believe, what you get in cocoa. You can also have the last one, cognition enhancers, still as part of the cerebral cortical stimulants. You can have the cognition enhancers and others, and you have the example of modafinil. I'll come with the structure next time. Modafinil, and we did mention that those ones are a little bit more selective, and they can be used as cognition enhancers. That is the first category, and the first category was the cerebral cortical stimulants, depending on where. So that is site where they are stimulating. They are the cortical, we call them cerebral or cortical stimulants. Then we have the second category, which we call the medullary or respiratory stimulants. Medullary or respiratory stimulants. And when we talk about the medullary or respiratory stimulants, these are the ones, like we have talked about these are the ones that can actually be used when you have a problem or you have taken respiratory depressants, then you can use some of these drugs. These agents act on the brainstem, specifically targeting the respiratory. But of course, again, always remember, nothing is cast on stone. There will be some intersection. There will be some. I mean, none of them will have just one activity alone. It will bind this receptor and bind. But we look at the major center it binds. To bind that major center, and it can bind the others, but to a lesser degree. So targeting the respiratory and vasomotor centers in the medulla oblongata. Things that you know better than I. And also they will bring about, they will also bring about vasoconstriction. And once they do so, they can have an influence. They bring about increased heart rate and all that, and they will increase your blood pressure. Generally act by reducing, and these ones act mainly by reducing the GABA inhibition. Again, that is not new. GABA is the main inhibitor and neurotransmitter. Once you inhibit it, then you will have problems. The other ones, and we had already said the adrenaline and bring about the sympathetic effect. So these ones are generally act by reducing GABA inhibition. And once they reduce the GABA inhibition, then they will bring about stimulation, and we have examples of doctor drugs that are not used. Those are drugs that have no use. They are also conversants, as we have said. Tetrazole, pictrotoxin are also conversants, camphor, and even carbon dioxide. Then we have the spinal stimulants. Again, as I said, they're not cutting stone. You can find one drug in spinal stimulants, like even picrotoxin. We have mentioned it just now as a medullary or respiratory stimulant. So you can still see it also belongs. So the spinal stimulant, these agents act on the spinal cord to increase motor activity, causing hyperreflexia, increased reflex. And again, you have strychnine, picrotoxin, they block their mode of neurotransmitter in the spine. Has two levels of activity. Remember when we were looking at the excitatory neurotransmitters, glycine. So you do have glycine binding the NMDA receptors act as a co-agonist for excitatory activity. So let's understand that. You have glycine binding as a co-agonist in the NMDA receptors, which are excitatory receptors. But you also have what you call the glycine receptors. The glycine receptors, which are usually inhibitory receptors, and they are bound by glycine. So glycine can bind it, their calcium, their channels, and they are inhibitory. I hope you do understand that. Or they can, of course, bind. Glycine can also gain so that receptors I have seen. These glycine receptors are receptors that are found in the spinal cord, and those receptors, being glycine receptors, bind glycine, and they are inhibitory receptors. So when they are blocked, then there will be stimulation. So kindly note those two ways in which glycine can bind receptors. You can have glycine binding as a co-agonist for the NM activity. You can have glycine binding like glycine receptors as an inhibitory receptor through calcium influx, just as we mentioned about GABA. And therefore, we have drugs again, like strychnine and picrotoxin and those drugs. Again, remember, drugs have different modes of action. So you again, this indeed can bring about conversions. These are very poisonous drugs. These are very bad poison. These are some of the poisons that people lace other drinks. Then you go to drinking places and you go showing everybody your money. Of course, those girls and those boys, I don't know whichever gender, they put strictly. Why don't you just carry enough or go where you are safe alone, and you make sure you go out with somebody who cannot also be compromised? Because these days things are very hard. You might go with your friend thinking they're your friend, and they say go and sell you. Go and get compromised and hapa and tunaona account yake ni mzuri. You can be able to get money out of them. And therefore you must, these days things have gone a while. Things are really, really bad. And that's no wonder they say you might know your friends. Is it your friends you know? Is it your enemy? I think these days it's hard to know both your friends and your enemies, because your friends can be your enemies, and perhaps your enemies sometimes can turn to your friends who can save you at a bad point. So, but what I'm trying to say is that even as you study these drugs, make sure that you use them to your own advantage. That you don't study these drugs and then when you go careless. And these days, it doesn't matter whether you're a lady or a man. People are sodomizing other people. Things are bad. After all, siku hizi kuna sijui mwanaume anaoa mwanaume, sijui mwanamke anaoa mwanamke. See, those things are there. I'm not the one who is saying that. They are there and they are happening. So everybody is. So all I can tell you, very soon you start earning 5 1s very close, bit closer than the 4 1s. But 200,000. Now you can't allow that money to stay in your account. You want to put it in your wallet, and then you want to go and expose to the world how rich you are. Utaona cha mtamakuni. Of them wake up completely messed up. In terms, even recovery is quite a problem. And because some of them, the other drugs they are given, like benzodiazepine, you wake up with amnesia, you wake up with terrible, terrible things. So kindly take care, because indeed, you are the custodians, you are the experts of drugs. Sometimes I say, if you have to take that drink, if you don't have somebody to go out with, or if you are the place is not your house, and be safe. Because let me tell you, it is no longer, we are heading to Sodom and Gomorrah. Things are very bad. Anyway, that's a story for another day. But when I discuss these things, I like telling my students, this information, let it not be for nothing. You come through university, you learn about drugs. Even if you don't get a very, very good job, or even if a pharmacy does, you will be cautious that you cannot take certain drugs and go and take alcohol. Or, and all those crazy things that people are doing out there. You can also be somebody who can mentor others. You can be somebody who can be responsible, even at home. Epilepsy, you can't be able, instead of this, you can tell them the risks of alcohol are this. The risk of mixing alcohol and diazepam is this, because this is what people are doing. So if you cannot help in any of this, then one wonders why you went. Anyway, that's a story for so many other days. So we have also talked about spinal stimulants, and I'm only talking about some of these drugs. Crude, crack people, very, very dangerous people, and they use it on the Kenyans or other people. and you find yourself in the morning in a trench or in a deep clean, you have been messed up physically, emotionally, and always. If we can be able to help ourselves, let us try to do so. The final category is the psychotomimetic stimulants, and the psychotomimetic, as you can see this name, the psychotomimetic hallucinogens. These are compounds, some of them naturally occurring, and these are compounds that will cause hallucinations. These drugs will to water perception, cognition, mood, producing effects similar to psychosis. And most of them, they will cause a lot of hallucinations. And we look at, when we come and look at the hallucinogens, we look at LSD, which is lysergic acid, diethylamide, cannabis. We look at what is in bang, whatever it is, and them that are also naturally occurring, and they have psilocin and psilocybin. And these are mother went, they were very desperate for food, and she went to the nearest bush, picked some mushrooms, children, and her and herself are all dead in the morning because they took an overdose, and these mushrooms are hallucinogens. So again, information is powerful and it can help us to avoid a lot of things. Classification, again, so that was classification as per their site of action. We can also classify them according to their mode of action, transmission, just as we have said before. So they increase they inhibit the inhibitory neurotransmission, which is GABA and glycine. So that is the main way for the specific class. So you have indirect acting sympathomimetic. It is because they are not acting, they are not binding the receptors, but they can bring about the release of the neurotransmitters. They can bring about the release of the neurotransmitters. They can block the reuptake of neurotransmitters. For neurotransmitters to be broken down, whether by the monoamine oxidases or catechol-methyltransferases, or whatever is breaking them down, they first must be taken up into the cell, because the metabolizing enzymes are found in the mitochondria of the cell. So if you give drugs that block reacting, if you give drugs that help to release, you do understand most of the neurotransmitters are stored in vesicles. So if you give drugs that can be taken up by the same systems, transporter systems, they get into the vesicles, they release the stored neurotransmitters. Again, they'll bring what we are calling excitation or stimulation. So you can have those different ways. So these ones you're calling them indirect acting, sympathomimetic. They can be monoamine releasers or reuptake inhibitors. They can block the metabolism, the release of the neurotransmitter. Stimulation by increasing the synaptic concentration of neurotransmitters like the dopamine and the noradrenaline. Mechanism, they enter the nerve terminal, promote the release of the stored catecholamines into the synaptic cleft. And we have examples of such drugs as amphetamine, dextroamphetamine, and methamphetamine. So they act as indirect sympathomimetic agents. So we are still on the indirect. That was the first one, was the monoamine releasers. The second one is the monoamine reuptake inhibitors. These ones will inhibit the transporter concentration because for them to be metabolized, it must be taken up. Mechanism, reuptake inhibition. And here you have examples of such cocaine, oxetine, the uptake inhibitor, the atomoxetine, atomoxetine for another in the uptake, but again, it will increase the levels of adrenaline. Modafinil moderates synaptic norepinephrine mentioned. Then we have the other class, so that was class number 1. We have the adenosine receptor antagonist, and this may influence on the cyclic adenosine receptors and inhibit the phosphodiesterase, which causes an increase in non-specific antagonism, which you've already mentioned, and I believe you already know them. Direct act on other receptors, direct action on other receptors, other mechanisms. You have nicotine. You ask yourself, why do people take cigarettes? Cigarettes when they say take cigarettes, they feel it somehow triggers the release of dopamine. And dopamine is a neurotransmitter that helps you to feel pleasure, feel good, and so on. So that is nicotine. And that is why, again, people get addicted to tobacco, people get addicted to cigarettes because they have nicotine. And the nicotine, again, will have a trigger for the release of dopamine. Glycine receptor antagonist, you've already mentioned that. Glycine receptor antagonist strictly blocks the postsynaptic inhibitory response to glycine. Again, we have mentioned that. GABA receptor blockers, we have also mentioned that these drugs inhibit the inhibitory neurotransmitter GABA, resulting in neuronal excitation, pentel, and tetrazole. So those, again, are some of the so those those are some of the other classifications according to the mode of action of the neurotransmitter. As we are moving along, we can also now, as a summary, also classify the CNS stimulants as respiratory stimulants, as the psychomotor stimulants, as the conversant stimulants, and the psychomimetic drugs. This you do it on its own as the hallucinogens. All these we do them as the CNS stimulants. So we look at psychomotor stimulants. If you classify them in as the psychomotor stimulants, and now we can therefore start. And you can are also the medullary stimulants, respiratory or medullary stimulants. You have given quite a number of examples. We have the doxapran, that is the ketamine, that is struck, they do not have any clinical indication. It mentioned doxapran because of abuse of like narcotic analgesics, abuse of barbiturate to trigger, or you can use such as respiratory depression. So that's the first category, which is the medullary respiratory stimulants. And as we have said, they really, apart from very rarely, are they used? Because again, when they cause respiratory stimulation, then they are dangerous lot. Then we have the next one, psychomotor stimulants or central stimulants or the sympathomimetics. And the sympathomimetics and the psychomotor means we have also the importance. We have the methylxanthines. We did put them under psychomotor stimulants, the xanthines. But of course, working for the through different methods. Remember, then causing differences in their mode of action. So the psychomotor stimulants or central stimulants, or what we call the sympathomimetics, we have the category. The amphetamines, the methamphetamines, and so on, they belong to the category we call the beta phenyl ethylamines. And if you look at this structure, I hope I believe you can be able to draw the structure of noradrenaline. Draw the structure of noradrenaline. Draw the structure of dopamine. Serotonin is an indole derivative, so that serotonin is a little bit different than indole derivative. But if you draw the structure of dopamine, you draw the structure of noradrenaline, you will see that those compounds have the phenyl. If is that they are the substituents that noradrenaline, they are catechoamines. So the phenyl ring has two hydroxyl groups. But when you look at this drug, because this drug, you must give them, they must be able to, most of them should be given orally. The group at the phenyl ring, of course, when you were mentioning, remember when you were mentioning apomorphine, we talked about stability. Whenever you have a catechol group, highly unstable because of oxidation on exposure to air. So therefore, when you look at these drugs, we call them beta phenyl. Beta phenyl, you can see that is a nitrogen there. That is the alpha carbon. That is the beta carbon. So the phenyl group is joined on the beta carbon because we can also have alpha. So if it is joined here, we call them alpha ethylamines because the phenyl group is joined to the beta carbon relative to the nitrogen. And indeed, they are structural analogs of noradrenaline and dopamine. So we have the first one we call amphetamine. And of course, when you come to look at the amphetamine, we mentioned that it has a chiral center, and the dextroisomer is the one which has the higher stimulatory activity. And when you look at amphetamine, the R there is a hydrogen. R1 is a hydrogen. R2 is a hydrogen. R3 is a hydrogen. And R4 is are actually hydrogens. The amphetamine is the rhythmic mixture, which will have, it is the dextroisomer, which has higher stimulatory activity. And of course, whether dextro or the rhythmic mixture, for sure it will have the same structure. Then you have the methamphetamine is a group, one of the groups that's attached onto the difference between methamphetamine and amphetamine. The only difference is that in methamphetamine, it is a secondary amphetamine is a primary methamphetamine is, or this was dextroid. Phenetamine, again, if you look at phenethylamine, again, very simple. So here is where there R2 apart from R2. And we will discuss what is the influence of putting those groups in the various positions. Because when you put those groups in those various positions, there is a change in the stimulatory activity. Some of these compounds, we say they are used as anorexins. Anorexians, and you find depending on the structure, the drug could either be an anorexant or a stimulant. So that we'll discuss much later. Then you can see benzathymine. Again, very, very similar. R here is a methyl group, and then R1 is also a very big group. So when you have those big groups, you know what happens, that there will be a decrease in the steric, there will be an increase in the steric hydrons, and accessibility of the receptor definitely will have a problem. Chlorphenamine. When you look at chlorphenamine, the structure again is still very similar. So of course, from the name, it is only that there is a group on 1, 2, 3, 4. 1, 2, 3. Here, a methyl group there, and a chlorine at that position. Again, you see that it much reduces the stimulant activity and brings in other activities. A phenyl propanolamine, again, hydrogens everywhere, and R3 here is an OH. What do we expect that to do? Of course, we do expect the hydroxyl group to increase the polarity, and therefore to decrease the ability of that compound to pass through the BBB. Fenfluramine. Again, fenfluramine, R1 is a C2H5, and M is a meta CF3, 1, 2, 3 at that position. Chlorphenamine, this was I will not discuss, even that one, but I know I will discuss. That one I don't have. I have this other one. The drugs that we call the cyclotomy, the beta-phenyl ethylamine derivatives, amphetamine and related drugs. Beta-phenyl ethylamines, and they have the structural resemblance to noradrenaline and dopamine. Then we move on. We are still on psychomotor stimulants. We have the octazolidinone derivatives. Why octazolidinone? Here ni octazole there. But of course, for it to be completely octazole, you will not have that. And you'll have a double bond there. So again, that is why we are calling it octazolidinone. Because it is not a complete octazole, but it is, and it falls in the class of not iso, but O, because the nitrogen and oxygen are separated with that. And again, if you look at that compound, and I would want you to look at it very keenly, you can still see your phenyl group. And then we go this way, carbon 1, we go that way there, carbon 2, and then we go to the nitrogen. And that nitrogen, it's only that it's double bonded there. But you can also be able, even in this structure, you can still be able to see the structural resemblance of this compound going this way with, again, the dopamine and noradrenaline. And no wonder they are psychotomimetic stimulants. And again, depending on what is on the nitrogen, depends. It is a tertiary amine and phenol secondary amine. So we have primary, we have tertiary, and we have secondary. And if again we look at them later. Then you have morpholinones, again not very new to us. The morpholin ring is acting that 6-membered nitrogen and oxygen. Let this not confuse you. This is a phenyl ring there, C6H5. That's a phenyl ring there. This is the phenyl ring. Tukuja hivo, one carbon. So one carbon there from the phenyl ring, second carbon, and we go to the next. So again, if you go this way, I hope you can be able to see that you have structural resemblance with another. They do have the activity. That we are seeing substituent, and that this substituent there that is found in noradrenaline, if you can draw that structure. Again, depending on what R is, when R is in, and then dimetrazine, dimetrazine, when R is a methyl group, because there is that methyl group and that methyl group there. So we call it dimetrazine when no structural similarity. Same pathometric agents. Sitting here and discussing the keyboards, discuss them. I just left it at that they do not really have any therapeutic indications. Because by the time we are finishing, we are getting here, we always have a problem with time. So I concentrate on those compounds that indeed do have some of them are subject to abuse, of course, like the amphetamines and methamphetamines, and some of them, of course, do have been used. Kuna swali, tulianza saa ngapi? Oh, I can't let me like somewhere there. We should be having, most probably, I'm hoping it's the last lecture, but we might have. Are you strong? We continue kidogo, mumeweza. Let me note that. I will do a recap on that. Let me do that next time. Croxazone. I believe it's a croxazone you want us to look at for the main one. Are we saturated? We to have democracy.
We can end there. It has been a heavy day.
It has been a heavy. Oh, then it means we are 56. Thank you for the students who are. And they reap the fruits of it. They are those ones who are just hanging by the streets. And when they can escape, but you see, when I look at your papers, when I look at the papers, then I'm not at the classes. And then at the end of the year, or when you go out there, you don't even want to meet me because your money week. I've been with you literally every day. And I'm there for you. So, I don't know. It's hard to understand. I never understand not going to class because, to be honest, I would last night, I would almost get conversions if I failed to attend classes. I never, ever, even with all the challenges out. I never, ever. Actually, personally, I don't understand when a student misses a, and it's very shameful, especially when you know some of your parents are denying themselves even food. Mimi najua wazazi wengine hata kukula hawakuli, They sell their shambas, wacha mtoto wangu awe daktari. Haya, unakuja unaona maisha, utaki kuja class, utafanyiwa nini? Utakufanyia nini sasa? What can we do as your lecturer? I can only be available. I know hata ukipeleka ng'ombe ikakunywa maji kweli utaishika na ushike mdomo uweke kwa maji. Hata hiyo mdomo ukiweka kwa maji na kukataa kunywa maji. So thank you for those who have been very consistent, for those who have been present. I only can say a big thank you. And you're doing yourself very good because it is building up a character. You're building up a character. Character that of a person who is responsible, who is consistent, who does not believe that I will, no, I'll have shortcuts. When I come to the main exam, nitafanya daktari huyu, nitafanya daktari huyu, sitafanya hii. Na hiyo daktari hiyo ulikuwa unataka kufanya ikiwa ngumu kushinda yangu. So you might fail for no reason. I mean, that is what we do have students who are, who scheme. And they scheme because they say, inajua hiyo end of year exam, it has so many, it has 4 lecturers, I can read for 2 lecturers or 3 lecturers, I will still make 50%. But unajua, hiyo nipata potea. And you see, when you go out there, remember you're supposed to be a master, not of some drugs, but all the drugs. But again, I'm thankful for those who have been present. Thank you very much. And I can tell you, in the future, one day, you will remember me. Because I can tell you, you will reap great. You reap great in whatever you do because that character is very important. Whereby you know your priorities, you set your goals right, and what should not be done with. So that, perhaps the other one will come ready. Even if you have break, we have a break and then we continue to see whether we can finish this, the stimulants, and then also look at the hallucinogens, and then we close the chapter. Thank you very much.